Chapter 4. The Electronic Structure of Atoms, Part 1. Part 1. Models of Atoms. Contents. Rutherford Model of Atoms. Drawbacks of Rutherford Model. Visible line spectrum. The Bohr Model of Atoms. Benefits of Bohr Model. Drawback of Bohr Model. The wave mechanical modern model. Rutherford Model of Atoms. Rutherford proposed an atomic model in which a positively charged nucleus was surrounded by negative electrons. Drawbacks of Rutherford model. There are some drawbacks of Rutherford models. First of them was if the electrons are stationary, they should have been drawn into the nucleus since opposite charges attract one another. Second, if the electrons orbited the nucleus, they should have radiated electromagnetic energy continuously. In this case, the atom would collapse. The Rutherford model couldn't explain why hydrogen or any other elements produced a visible line spectrum. Visible line spectrum. When an element in the form of a gas at low pressure is excited by heating or electricity, it emits visible light. When this light is studied, it is found to be composed of regularly spaced lines. Each element has its own characteristic visible line spectrum by which it can be identified. The Bohr model of atoms. In 1913, Niels Bohr, a Danish physicist, proposed his own model of hydrogen atom that was able to answer many questions that had confounded Rutherford. In order to do so, Bohr had to make a number of assumptions based on the revolutionary ideas first proposed by physicists Max Planck and Albert Einstein. The Bohr model of atoms. Bohr proposed a planetary model of the hydrogen atom just like Rutherford. In Bohr's model, the electron behaved most unusually. According to Bohr's model, the electron could orbit only in certain specified levels, each of which represented a distinct amount of energy. The more energy associated with the level, the further it was from the nucleus. These energy levels are called principal energy levels and they were said to be quantized and were designated by the letters K, L, M and so on. We now designated principal energy levels by number 1, 2, 3, 4 and so on. The Bohr model of atoms. The lowest energy level, 1 for hydrogen, was called the ground state. Other levels were called excited state. Since the electron could have no lower energy than ground state, it could not come any closer to the nucleus and therefore it remained stable. In a given orbit, an electron never radiated or absorbed energy. In this case, the electron was said to be in a stationary state. If an atom absorbed exactly the right amount of energy, the electron would rise to a higher energy level. Conversely, if the atom released energy also in exact amount, the electron would fall to a lower energy level. The energy that was released appeared as a photon of light. Benefits of Bohr model. Using Bohr model, reason of spectral lines can be explained. Bohr recognized that spectral lines are the result of electrons falling from higher energy levels to lower ones. By applying mathematics to his model, Bohr was able to account precisely for each line in the visible spectrum of hydrogen, which itself provided strong evidence for the correctness of Bohr's model of the hydrogen atom. Drawback of Bohr model. Bohr model worked well for hydrogen atom, but it didn't work well for other atoms, even helium, which has only 2 atoms. The wave mechanical modern model. The modern model of the atom is based on the premise that an electron and all other matter exhibits both particle and wave-like properties depending on the circumstances. We can pinpoint the exact location of a particle, but we can not do same in regard to a wave. Therefore, we use alternative method to describe an electron. We must be content to guess where it is probably located. We use electron cloud. An electron cloud is a distribution of probability. It is thickest in the region where we are most likely to find the electron at any given moment, and thinnest in the region where the electron is least likely to be. In the modern model of the atom, an electron in an atom is described in terms of a concept known as an atomic orbital.